Okay, this is lesson 7. We're changing entire and mixed radicals back and forth. We looked at converting square roots. Now we're going to look at converting cube roots. So when we looked at square roots, we were dividing by perfect squares. This time we're going to divide by perfect cubes. So now we're looking at indexes of 3, and they have to show us that index. That's how we know we have a cube root. So if I want to convert that one, the first thing I do is I find that 54 is in between 27 and 64 on my list. I'm not looking at the guys on the left. I'm looking at the guys on the right. So my numbers, 54 is in between those two. So that means I have to divide by the numbers above it, okay, the smaller numbers. Everything divides by 1, so we never use 1. So I would start with 27, and then I would go to 8. We're going to notice 27 works right away. So we have cube root 27 times 2, and now we split them down. I usually just split them down right away, whichever you like. Then we have our cube root of 27. We're going to solve it. So this one actually solves, and we cross it out. It becomes a positive 3. If they wanted a negative 3, under a cube root sign, you can put negatives now. Under square roots, no way, Jose. But under cube roots, yes, you're allowed to. This one is a positive 3, so we only bring out positive 3. So the cube root 2 will not break down. If you notice, 2 is between 8 and 1. Everything divides by 1. So basically, any number lower than an 8 is considered reduced. Okay, so our final answer is 3 cube root 2. They just sit side by side. Okay, so 3 cube root 2. All right, let's take a look at all of these. The first thing I'm going to say is if you see a number with 3 zeros, it's automatically going to divide by 1,000. So this guy here, just like we did before when we talked about numbers that ended in 5s, we would divide it by 25 if it was a square root. These ones are cube roots. So these guys, we're going to put our perfect cube first, always. And yes, it does matter. So the perfect cube goes, and then the final one goes. So I have 1,000 times 6. 1,000 times 6. Now, your cube root of 1,000 is going to solve. We're on page 49. So the cube root of 1,000 will solve, and it becomes 10. The cube root 6 is just going to slide beside it. Now, you have to show that index of a 3. If you write me 10 root 6, that's very different. That tells me that 2 10s multiplied to go under, whereas the previous one with the cube root sign means that I needed 3 10s. 10 times 10 times 10 is 1,000. Okay, so remember, the index tells you how many of those numbers you're using. All right, 320. Well, if we take off a 0 and then we look at the number 32, what does the number 32 divide by if I look at my list up here? Right, 32 is going to divide by 8. Okay, but a multiple of 8 is 64. So 8 times 8 is 64. So what we do is 320 is in between here. So we would divide by all these numbers lower. So I would divide by this one. Doesn't work. Divide by this one. Doesn't work. Let's try 64 and see if 64 works. It's a multiple of 8. Does it work? Anybody? No, it doesn't. Does 64 work? Let's try it.
Yeah, it's 5.
Is it 5? Okay. Perfect. Thank you. So we have cube root 64 times cube root 5. All right. And now the 64 is the one that's going to solve. So 64 becomes 4. You bet. So we have a 4 cube root 5 all by itself, and we are done. Now the next one, we're showing a negative number. So whenever we're showing a negative number under a cube root sign, the negative one is the guy that comes outside, okay? Because it's going to break down into one number that's positive, one number that's negative. So here, this guy's going to divide by 8. That's the only number lower than him, and 2. So 8 times 2. So again, where am I looking? I'm looking on this chart, if it agrees to come down, and I'm looking right here. 16 is in between those numbers right there, so I have to divide by 8. 8 does work. So when I do the cube root of 8, I'm going to get a 2. So we cross off the cube root sign. It becomes a 2. It loses its root sign completely. So I get 2 cube root 2 as soon as it's going to come up here. Whoa. 2 cube root 2. All right, the next one, now we've got a fraction we're dealing with. That's the only difference on the next example, is now we're going to deal with a fraction. So it says to convert fractions, it's easier to take the number that's underneath there already and make him into a fraction. And if you don't want to, that's fine. All you got to do is put your fraction in brackets. So that's one hint we need to write down is fractions get brackets. Always. They go inside brackets. Okay, so that means under here, I'm going 1 over 2, and I'm going cubed. So I'm going 1 over 2 cubed. So if I'm going 1 over 2 cubed, that means I have 3 of those 1/2 numbers. I've got 1/2, 1/2, 1/2. That's what that means. So 1/2 times 1/2 times 1/2. And what is 1 times 1 times 1 give me? Just 1. And what is 2 multiplied by itself 3 times? What do you get? 8. Good. So that's going to give me a 1 over 8. And that's what we insert right there. 1 over 8. And now again, it needs to be in brackets. So I'm going to put it in brackets. And now we're going to go to those handy dandy calculators of ours. And we're going to literally type it in using brackets. So in my calculator, this is what I'm going to type in. Bracket 1 divide 8 bracket times 80, enter. If it turns your answer into a fraction, sometimes it's a fraction, you might get a long decimal, then you math bracket. This one's not. This one's going to give us an answer of 10 because you're going to get 80 divided 8, which is 10. Now, if you wanted to put the other number into a fraction, you would use fraction rules, which means multiply your tops, multiply your bottoms. And all that gives us is exactly 80 over 8, which divides and gives us 10. So what we end up with is cube root 10 in the end. We don't end up with fractions at all. Sometimes we do, but sometimes we don't. Sometimes the fractions completely reduce and become whole numbers. So that would be our final answer. Now remember, that's very different than just writing root 10. Okay, so you have to have the proper index. Without that proper index, that's telling you something very different. This one here tells me 2 numbers multiplied to give me that 10. Over there, it's telling me 3 numbers multiplied to give me that 10. Okay, that's what that's telling you. All right, turn your page. We have a couple to convert. So now we're going to entire. So again, we're going to take the ones that are out front and we're going to put them under. We use the index as a little exponent. So this one is a 4th root. So to take the 2 underneath, he's going to use that 4 as an exponent. So I'm going to go 2 exponent 4 times 3. And that's what I'm going to type in my calculator. You're not typing the root sign in. What you're typing in the calculator is what I'm going to highlight. You're only typing this part in. That's going to solve what's under your 4th root. So 2 to the 4th power is 16. We get 16 times 3 is 48. So this turns into 4th root 48. The next one, it's a negative. Because I have a cube root sign, I'm allowed to take it underneath. So the negative comes under, and it becomes, when you take a negative under, you always put it in brackets, just like a fraction. He gets cubed times 7. So in your calculator, again, you would use those brackets. So you have a negative 3 in brackets cubed times 7. So again, in the calculator, you're only typing the radicand, the stuff that's under the root sign. Your final answer is going to end up being a negative, and you're going to get negative 448 because you're going to get 64 times 7. Okay, negative 64 times 7, which gives us negative 448. The next one's another cube root sign, but it's a fraction. So I need to take my fraction in brackets, cube root sign, bracket, 2 over 5 cubed times 100. Now I'm going to grab my calculator, and I'm going to get my calculator, and he's going to show us what to do on that one. So with our calculators, we're going to type this in. All right, calculator, come on. Come on, calculator. Agree and proceed. Accept. Oh, come on, come on. Okay. Opening our calculator. First thing is brackets. So bracket, and now we're going to put in the 2 divide 5. 2 divide 5, close your bracket. And now you're going to use the cube sign. The cube sign, you can either use the TP, this one right here. This is your power sign for any exponent. But to put a cube sign on, it's math 3. If you just hit your math 3, it'll do cubed. So I'm going to hit math 3. So I get my cubed sign. So it's going to multiply now by the other number under there, which was the number 100. So times 100. And that's going to give me my answer. Oh, darn, it's a fraction or a decimal. So now I got to convert it to a lowest term fraction. So I hit math, enter, enter. So I got 6.4, which turns into 32 over 5. So now on my sheet, I know that this guy turns into 32 over 5 because I got a 6.4 answer. And that's what that guy's going to give us. So it'd be like cube root 6.4, but we always convert the decimals to fractions. Okay. All right, last one on there. The negative sign, because it's a fourth root, are we allowed to take the negative in? No. If it's an even numbered index, you leave the negative sign outside. So we leave it outside. We put our fourth root up. Now we take the 3 and you put the 4 on it. So 3 to the 4th times 2. If it's not a fraction, you don't really need the brackets, or if it's not a negative under there, you don't really need the brackets. I'm just used to inserting things in brackets, so I'll just take those off for you in case you're confused. But it's just 3 to the 4th times 2. That's all that's going on. All right, the negative stays outside. And we would go 3 exponent 4, which gives us an 81. So 81 times 2. Now, sometimes if you need to solve them and you don't want to write the full next step, I'll show you how to show your work. All you're going to do, so for this question right here, I would have put negative 64 on top of that guy. And then I know I need to times negative 64 by 7. Up here, I would have put 81. Come on, 81. And then I know 81 has to times by 2 now. So now I'm going to get 162 underneath. Okay, so when you solve these, if you want to put them up top, that's totally fine. Okay, because then it reminds you what to do under there sometimes. All right, last piece. What do we do if there's variables? Oh, darn. Well, we do variables. So whenever we talk about variables and we're multiplying, so if we multiply variables, if you remember with exponents, If you have the same base, if the base is a digit, if it's the same digit, you can add your exponents. If the variable is the same, you can add exponents, but that's only if you're multiplying. If you're dividing, same rule, but you would subtract exponents. But they have to be identical bases. So if we look at this question right here, the x would be our base. The exponent is that baby number. So here I've got 3 and 3. I would add them, and that's how I get the 6. Okay, that's how I get the 6 there. Now, then I would put it under the cube root sign. So if it's saying, okay, well, what is the cube root of that then? Well, it's x to the 3. So what are you noticing happens to the exponent? What happened to that 6 to become a 3? What happened to it? It halved. It divided by 2. So that's a very good explanation. You're always going to take half of the exponent. To solve a root. So to solve a radical. So you half it. You always take half of. If it was an 8, you'd divide it by 2 and get 4. If it's a 10, divide by 2 and get 5. So this is a 6. We take 6, divide 2, cut it in half. We get 3. And then we look at our original. We had x3 and x3. So we got what we started with. That's what we wanted. So now if I take all these 5s, take a look. I've got 3 different 5s. So 5 plus 5 plus 5. We're multiplying. Kick the multiply sign over. You're going to add exponents. So I got 15 on my x. So now I know that the cube root of 15 then is, but now it's cubed. So I'm not going to divide by 2. I'm going to divide by 3. Good. So for cube root, you're taking 15, divide 3 equals 5. So you're going to get x to the 5. So you take half of the exponent to divide a root. You divide 3. So you're basically dividing by the index. So you divide by the index. And that means taking it out of the root sign. So if you want to solve a root, you're dividing by the index. So let's say I've got this one. I'm just going to put a different one down here. Let's say I've got, fourth root x to the 20th, x20. So if I wanted to solve that, because it's a fourth root, what would I divide 20 by? 4. You just divide literally the exponent by the index. So this guy's answer is going to be x5. So what it means is you took 4 of those x to the 5s and got x to the 20. That's what that's telling you. So you had 4 of those x to the 5, x to the 5, 4 of them. That's what that's telling you. And they're all timesing. And that's how you get your 20. So if I want to fourth rooting it means divide by 4. And that would be all of your exponents. So let's say you've got 2 letters under there. So with my fourth root, I've got my x20. What if you had y24? What if you have y24 sitting beside it? Well, you'd still do the same process. You would take 24, divide 4. So this guy right here, you're taking 20, divide 4. And here you're taking this guy, divide 4. And that would be your answer without a root sign. So your answer would be x5, y6. Done. Okay? That would be your answer without the root. Any questions about that? Let's take a look at those bottom examples there. So this one here says x to the 4. Well, I'm going to take 4 and divide by my index. So dividing by 2, which means I'm going to get x to the 2. That's how I get my 2. So we're dividing by the index to remove it removes the root sign, to remove the radical sign. That's the whole point we're doing this. We want to remove that root sign, which means we're solving it. So y to the 10. 10 we're going to go divide by what? What's our index there? 2. Good. Whenever it hides, it's an index of 2. So that's going to give us y 5. Now we got 2 letters underneath there, but my index is a 2. So we're going to divide both of these guys by 2. So I'm going to have an A4 and a B3. Now the other one right beside him has an index of 3. So that means we're taking 24 and we're dividing by 3. So that's going to give us x to the 8. And again, that little 3 means I had 3 x to the 8s. Okay? Just like it's showing us here on that one, that I have 4 of them. That one would mean I have 3 x to the 8s. Okay, I have an index of 3, so I am dividing my 6 by 3. That's going to give me y squared. Y to the 2, yeah, y squared. Now what's actually going to happen? What if it doesn't? What if it's an even root, but you have an odd exponent? That's what's going on the next one. So this guy is an odd exponent under an even root. Well, you can't take an even root out, so you have to split them. This is where you split. So you're going to split it into something that can divide by the index. Well, what numbers can divide by the index? A 2 and a 4. You're going to take the largest one. So this guy, they picked a 4 and the 1. So here I've got x to the 4. Here I've got x to the 1. Now remember, I want to remove the root. So I'm removing my radical sign, which means I'm solving it. And in order to solve it, I'm taking 4 and dividing by my index of 2. So that leaves me x squared out front. So we're going to slide them back side by side. So my final answer is going to be x squared root x, and he's got a hidden baby 1 on him. Okay, that's that hidden baby 1. He's got exponent underneath. Okay, we've got a hidden 1 there. If you want to draw the 1, you can, but that's how he ends up. So you're always taking out whatever will divide by the index. If it was a 6, if the number was a 7, I would take 6 out because 6 could divide by 2. So any even number, but take the largest one. So now we're going to reduce these ones. So these ones, I'm going to have to split this guy into a to the 6 and a1. A1's going to stay a1. 6 I'm going to divide by 2. Why am I dividing by 2 and not a 3? Because my 2 is my index. So I'm going to get a3, and then I put my root a to the 1 beside it. So that's what my answer looks like. A3 root a. What would I break a 9 into? 8 and 1. Good. So this guy's going to go, I hate using the letter T because it looks like a 1. I'm going to make him an X. It just drives me nuts with the letter T. Okay, I get x to the 8 and x to the 1. You're always taking out the largest amount of even numbers if it's an even root. So what's half of 8? 4, good. So we're going to x to the 4 comes out, and my root x1 stays. Now the next one is a cube root. So now what am I breaking the numbers into? Would I be 4 and 1? It's a cube root this time. If it's a cube root, I got to break it down into a number that divides by 3. And the only number that divides by 3 that's less than 5 is a 3. So I have to break it into 3 and 2. So this guy's going to break into cube root x3 and cube root x1. And everybody's going to ask me, but Miss Tuck, do I have to show these? Can I just write root x1? No, you cannot. That is a very specific thing you need to write is the index. Because if you just write the index without that, or if you write the root sign without the index, that's telling me it's a square root, not a cube root. So now this guy's going to solve. 3 divides by 3 one time. So we're going to get x to the 1 cube root x to the 1. No, you don't have to show the ones, but I'm just showing you how many are left over. What's that? Oh, it's a 2. You're right. My bad. It's got to add to 5. Here, let me fix that. Good thing someone's paying attention. Add a B, Jamie. All right. So yeah, 2 and 3 make 5. So that guy breaks into a 3 and a 2. I said 2 and wrote a 1. Okay, what about 7? If I have the number 7, what can I break him into if it's a group of 3? 6 and 1. Good. So this guy is cube root x6 and cube root x1. So we know we're going to end up with a cube root x1, and we have to solve this guy. So when I solve that one, what's 6 divide 3? 2. Good. So I'm going to get x squared out front because I'm going 6 divide the index 3. And that's how I get 2. Okay, that's how I got 2 as my exponent. Now we're putting a whole bunch of letters and numbers underneath, and we're like, okay, simplify. Oh boy. All right, simplest form, let's go. All right, it's a square root. If it's a square root, we have to break it into groups that can divide by 2. So on our x, I have a 6. Can 6 divide by 2 by itself already? Yes. So the x doesn't have to change. But does the y have to change? Yes. So we're going to break it into this. x6 y4 times root y to the 1. So one guy's only going to have a y underneath it. The other guy's going to take all the x's. He's going to take all the x's because they can all divide by the even number 2. So we're dividing by 2 in this one. And that's what's going to solve these guys. So I know I've got an x, and I've got a y, and I know I've got a root y. Now let's put our exponents on. So half of 6 is 3, and half of 4 is 2. And then my y to the 1 stays underneath. Okay, your y1. So we got to split them where you can divide them evenly because it's an even index of 2. Same thing on the next one. We have an even index of 2. So 18, we have to do the digit and we have to do the letters. So now it's a perfect square again. We're dealing with digits. 18 will divide by 9. So I know this guy is going to break into 9 and an x to the 2 because I can take out x to the 2. And then what does 9 have to multiply to give you an 18? 2. And then how many x's are left over if I take 2 away? 1. Good. So 2x1 is going to be left underneath. So in this question, what makes it extra, a little bit more difficult, is we are now reducing the 18 to a perfect square and what's left over. And then we're reducing the variable that has to add to 3. So the variable digits have to add to 3 on their exponents. We take out groups of 2 so they can divide by 2. So now we're solving this one. Okay, we're solving the one that's got the perfect squares. So what is the perfect square of 9 solve to? 3. What does x to the 2 solve to? 2 divides by 2 once. And then your root 2x1 stays underneath. So we took our x and we divided by 2. So we have 2 divide 2 equals 1. That's what's going on with those x's there. My goodness. It won't let me put a divide sign. There, divide. Okay, the next one, we have to do the same thing. 32 is going to split. First of all, for digits, into 16. And the other one's going to be left over is a 2. 16 times 2. Now, how many 7s can I take out that will divide by 2? 6. So a 6 and a 1. So I got to bring y6 to the left, y1 to the right. All right, how many z's can be taken out? All of them? Yes, because it's an even number. So z8, which side is it going to go on, the left or the right? The left. So z8 under the root sign. Okay, now we're going to solve that perfect root. So we're solving that guy. He's going to become 4. Square root of 16 is 4. I take half of each letter. So half of 6, whoa, come on back down. Half of 6 is 3. Come on. It disappeared on me. Hang on. It's thinking. Come on, be good to me. Let's go. Okay, so we have 4, the square root, on our y's. We take half of 6, gives me 3. Z, half of 8, gives me 4. And my leftovers stay under the root sign. My next one, I'm dealing with a cube root. When you're dealing with a cube root, all you're doing is looking on the cube root sign, and all of your letters have to be able to divide by 3. So 40 is going to divide into 8. So cube root 8 and cube root 5. 8 times 5 is 40. Okay, and now we need the x's. The x's I need to split into a group of 3. So it's going to be x3 and x1. And now the y's. The y's, can the digit divide by 3? Yes. So which side does he go on, the left or the right? The left. So y9's going over here. Don't forget to keep your indexes where they belong. That's looking crazy. Come on. Well, that's a 9. All right, we're going to solve that one. Cube root of 8 is 2. x3 divide by 3, x to the 1. y9, what's 9 divide 3? Good. So we're going to get y3 out front. Our cube root sign goes back, and my 5 and my x1 go back underneath. Those are my leftovers. So the leftovers stay on the right, they stay under. The ones you take out, they go outside. Last 4 examples. These ones we're going to do the opposite of what we just did. So we're taking what's outside, and now we're going to bring it under. So instead of dividing by the indexes and breaking them into groups, instead of dividing, we need to be able to multiply by the index. So this guy's index is a 2, so I'm going to be multiplying by 2, same as this guy. And same as that one. So the first thing I'm going to do is I'm going to write my root sign. And what do I have coming underneath my root sign? Well, I have a 2. He's going to get squared. He's going to take that index as an exponent. So I get 2 squared times x3. 2 squared becomes 4. x3 stays the same. So I get 4x3. The next one, A2, the 2 is going to times by 2. So here I get my 2 times 2 for my exponents to give me A4 times a to the 1. Now when we times exponents, we add them. So 4 and 1 make 5. So my original root of this guy would be A5. That's what he would have started as. So what we're doing is trying to find out, what did the beginning numbers look like? What did the beginning letter look like? X to the 5. Here we're going to go 5 times 2. So under the root sign, I'm going to get x10 times x1, y1. The only thing I can add there are the x's. So 10 and 1 make 11. So now under my root sign, I'm going to have x11 and y1. Very similar for the next question, only this time it's a cube root. So we are going to cube the numbers going in, meaning timesing the exponents by 3. So on that x, there's a hidden 1. So I'm going to make a big cube root sign, and now I'm bringing everything under. So in brackets, I bring my digits. Digits have to go in brackets because if it's a negative, you need to realize that that negative belongs with that digit. That's why they have to go in brackets. So 3 cubed x. Now what's 1 times 3 is going to give us our x number. And then we've got 3 times 3 to give me my y number. So I should get y9. So now I've got what? Reload. Refresh.
Officially 9:20. That was when your computer then, or TV, then faulted out.
Again. Come on, I hit play. Okay, as you can see, we multiply this number by the 2 to get our 54. There's nothing to add to each of our exponents, so they write them final underneath the cube root sign. This concludes lesson 7.